Hi, and welcome to part 2 of our tour of the solar system. In this one, we'll be looking at the gas giants. But before then, roll the intro. We pick up where we left off last week by entering into the asteroid belt. The asteroid belt contains nearly 2 million asteroids over a kilometre wide and millions more smaller ones. There are even objects within the asteroid belt so large, such as Ceres, to even be considered dwarf planets. Beyond the asteroid belt we have our first gas giant, the largest planet in the solar system, Jupiter. Named for the Roman king of the gods, their equivalent to the Greek Zeus. Jupiter is an astounding 70,000 kilometers wide. It's so large that inside of Jupiter you could fit more than 1,300 Earths. Jupiter's massive size and largely hydrogen atmosphere have led some to speculate that if Jupiter had continued to gain mass when forming, it may have achieved a stable nuclear fusion reaction and become a star. However, it is thought that Jupiter would need to be about 80 times larger for this to have been possible. Jupiter is home to the famous Great Red Spot, an enormous storm more than 3 Earths wide. This storm has been observed since we first had a clear observation of Jupiter, meaning it has been raging for at least 190 years, though it may be far older. Jupiter has about 79 moons, though the actual number may be even larger. Some of these moons are actually the most interesting things about Jupiter. This includes the icy moon, Europa. Beneath the 15 to 25 kilometer thick crust of ice on Europa, there is a 60 to 150 kilometer deep ocean. This huge body of water is widely considered to be one of the most likely places outside of Earth for humanity to find alien life in the solar system. There is, however, another icy moon in the solar system which fits this description: Enceladus. Enceladus, much like Europa, has a thick icy crust and is an excellent location for the search for extraterrestrial life. Furthermore, the probe Cassini detected molecular hydrogen coming from Enceladus. This may be a potential marker for the presence of deep-sea hydrothermal vents at the bottom of Enceladus's seas. Here on Earth, the hydrogen sulfide gas emitted from hydrothermal vents support vast ecosystems without the need for direct sunlight. This presents a solution to the inability of sunlight to penetrate the thick, icy crust. Enceladus orbits our next gas giant, Saturn. Saturn is the second largest planet in the solar system, though despite its enormous size, it's not as massive as you might assume. In fact, Saturn's relatively low density means that if you could find a body of water large enough, Saturn would actually float. Saturn is perhaps best known for the rings which orbit it. In fact, all of the gas giants have rings. Saturn's rings are just far brighter. This is in part due to their composition and their size. The rings of Saturn are mostly made of chunks of ice, some of which are as large as the average house. This ice is relatively reflective, giving the rings their bright appearance. These rings have an impressive diameter of 270,000 kilometers. Meaning that with the rings, it more than doubles the total diameter of Saturn. Moving on from Saturn, we have Uranus. Uranus has a very unusual rotation, rolling on its side instead of rotating on its axis. One hypothesis which aims to explain this is the possibility of a large object, possibly even one of Uranus's own moons, crashing into it and shifting the axis of its rotation. This, however, is not the only notable thing about the moons of Uranus. All but one of Uranus's moons have a retrograde orbit, orbiting in the opposite direction. Uranus's atmosphere is comprised mostly of hydrogen and helium. However, an impurity of hydrocarbons, such as methane, give Uranus its blue coloration. The presence of hydrocarbons and intense pressure allows for an interesting phenomenon: diamond rain. These diamonds are then whipped around by winds of up to 560 miles per hour. So if you're now thinking that going to Uranus to collect diamonds sounds like a good idea, you may end up looking like Swiss cheese. The furthest planet of the solar system does, however, also have diamond rain due to the presence of hydrocarbons in the atmosphere: Neptune. Neptune was actually predicted to be there with astonishing accuracy after irregularities were noted in the predicted orbit of Uranus. These irregularities could be explained by a large distant object whose gravity was having an effect on Uranus. Predictions were made based on this, and sure enough, from these predictions, there was Neptune. One of Neptune's moons, Triton, is one of the coldest places in the solar system, with temperatures as low as minus 235 degrees Celsius. Beyond Neptune and its moons, however, is interstellar space, vast areas between an unknown amount of star systems, containing an unknown amount of planets. And sadly that does bring us to the end of our tour of the solar system. I hope you did enjoy. Please do share, like and subscribe, and carry on learning. Bye!